In this example, we want to find the rank of this matrix, which means you want to row reduce this matrix and look at the number of pivot elements or pivot columns in the row echelon form of the matrix, and that will tell us the rank. We can start the row reduction process. We see we already have a 1 in the first slot here, so we can go ahead and use that 1 to get rid of everything beneath it in the matrix. So the first row stays the same. I want to subtract 2 copies of row 1 from row 2, so that puts a 0 here. 1 minus 2 times 5, negative 9. Negative 1 minus 2 times 2, 3. Negative 2 minus 2 times negative 1, 0. And negative 1 minus 2 times 1, negative 3. For the next row, we leave it unchanged because there's 0 already in that spot. For the first row, I want to add 1 copy of row 1 to row 4. So 0, 0 plus 5 is 5. 3 plus negative 2 is 1. 1 plus negative 1 is 0. 6 plus 1 is 7. And the same thing for the last row, adding 1 copy of row 1 to it. Next, we want to get a 1 into this slot here. So to do that, I'm going to divide the entire second row by negative 9, which I'm okay with because these will both be 1/3 here, so it's not going to be too bad of fractions at this point. Everything else stays the same except for dividing that row by negative 9. And I want to use this 1 to get rid of all the 3 entries beneath the 2, 5, and the 8 that are there. Now the first 2 rows will stay the same. I'm going to subtract 2 copies of row 2 from row 3. So the 2 will go away and become a 0. 3 is 9/3 plus 2/3 is 11/3. 0 stays a 0. 8 is 24/3 minus 2 is 22/3. For the fourth row, I'm going to subtract 5 copies of row 2 from it. So a 0 there. That's 1 is 3/3 plus 5 is 8/3. 0 is still a 0. 7 is 21 minus 5 is 16/3. And then the last row, I'm going to subtract 8 copies of row 2 from it. So a 0. Minus 4 is negative 12/3 plus 8/3 is 4/3. 0 and negative 8/3 in the last row. And as we see, all of these now are of the form something and double that something. So we could stop here knowing that we're going to get exactly 3 pivot columns, or we keep going. And if we keep going, this will turn into, and then when I do the row reduction, all of this here goes to 0, which then leaves me with the following row echelon form of that matrix. And since I see 3 pivot 1s, 3 pivot columns, that means that I have 3 linearly independent columns. It also means I have 3 linearly independent rows, which means the rank of this matrix is 3. Let's use the process of row reduction to reduce a matrix to figure out what the rank of that matrix is, which is equal to the number of linearly independent rows and the same as the number of the independent columns of that matrix.